Morning everyone. This is the second video I've been making. Wanted to say thank you to those of you who've watched the first and have already participated in the forum. That's really good. Thanks also to Zach for suggesting an improved video making method. I'm afraid, as you can see, I haven't used it yet. That's partly because I'm a little pushed for time. I'm about to see my year 13s and I want to get this out this morning. My phone and the Wi-Fi network that the laptop are using are different. So hopefully when I make the next one, I'll have had more time to fix up a better way of making these videos. But for now, we are going to whiz on. Let's say I'm a little pushed for time. We're going to whiz on with the repair lesson. So your homework, of course, for today, for Friday, the 20th, was to go over your key assessment in Purple Pen. And we're going to talk about a few of the questions that people have struggled with. So, for example, we're going to be talking about 1.1 and 7.1, 2 and 3. So, if you want to pause the video and have a flick through your key assessment, that now might be a good time to do it. I'll make sure you can easily see the key assessment and some of the other resources in the forum. Okay, but let's worry about this. Going through this first. So have your copy to hand as we do this. This is my annotated mark scheme. And yeah, 18 minutes till I'm due to see my year 13s, so we'll crack straight on. Right, question 1.1. He says, dropping his key assessment. We had this question before on a previous key assessment, and I know it sounds picky, but the separation, how's this working? Separation between your ions is important. I'm still penalising people for separation there. Okay. Otherwise, that was the only main problem with this one. Just take care with your exam technique. That question was about sodium. That question about sodium chloride. Okay. So yeah. Question 2. Mostly quite well answered. This is the longer written one. A lot of us forgot that the whole question is about silver nitrate. Okay, a lot of us were very good at remembering we can dissolve stuff in ammonia. That's actually irrelevant on this occasion because we can identify all three of the given ions without doing the ammonia bit of that test. So I'm afraid if you wrote a lot of details about that, you got 0 for that chunk. General things about this one. It is the practical that we did, by the way, and actually we did this exact question as well following it. Some very good answers off the top of my head were Abby and Alian, so well done to you. There were others, but can't quite remember off the top of my head at the moment. Things that we missed. Sometimes you'll see, you can't see that at all. Sometimes you'll see, of course, that I've written an approximately symbol. Approximately 1A, approximately 1B, if you sort of hinted at the marking point I was looking for. Okay. So the question tells us that we've got some solid samples of some halides. So we need to dissolve those in water to do the reactions with them. You need to name an acid. A lot of you suggested hydrochloric acid. That is a bad idea. I mean, not such a bad idea in this exact question, but hydrochloric acid contains the chloride ion, which responds to some of the tests we would be doing. As you look back in your notes, we'd rather use the nitrate ion, so nitric acid was a thing to use. What else? Oh, silver fluoride. Because you asked about some equations, a lot of you wrote silver fluoride, silver and fluorine. Let me start again. Ag plus F minus going to AgF, and all those were aqueous. You don't get any marks for that because it's not a reaction. We've gone from 2 ions that are in solution to 2 ions that are still in solution. Okay, the same ions. So the reactions were the bromides and things. Okay, that is going to form part of. Let me just make a little note to myself. We're going to talk more about that question later. Okay, I am whizzing over. Of course, the forum is there for questions about things I haven't mentioned in the video and so on. If there's loads of questions about the same thing, I can do another video. Hooray. So, question, we've done that one. 3.1. Mostly okay. Oh, well, two things actually about this whole question. The first thing, this was a part of your self-study topic. There was a whole chunk of the Group 7 topic I asked you to do in self-study, looking at things and writing them down. That's just as important as stuff I write on the board. You know, it's all well and good for me to shine a slide on the board with a reaction and say copy this down. You could be at home looking at a PowerPoint and copying it down. It's just as important if we've done the second thing. Okay, so that these self-study topics are going to be especially important at this time. Okay, so just bear in mind, you know, even if I ask you to do something entirely independently, it's just as important. And then in lessons we'll do some practice on it, like this, which revealed an issue. The issue was, if we're talking about electronegativity, then we are interested in the attraction of that nucleus towards a bonding pair of electrons, okay, a shared pair of electrons in the covalent bond, not the outermost electron of the atom. Okay, so for shared pair, says the mark scheme, which you'll be able to see. So it's telling me which electrons we're interested in. The equation and the observation in 3.2 was done very badly. Look back at the start of the Group 7 booklet. It's the self-study thing again. Whizzing on, 4.2 and 5. Yeah, okay, question 4 is one of those big moles calculations one. And I was quite impressed with most of you with how you approached it. There's a few things to be aware of. Well done to Nimra and Dawud in question 4.2. I don't like question 4.2. I think it's harsh because you're looking at some results a student has been collecting, and the student has made life difficult for themselves and therefore you. So a lot of you are thinking about how many decimal places to be leaving things to, and unfortunately the students decided to do it differently for different titrations. The rough one, because they're being a bit rough and they're not really checking exactly how much to add in, they've only done to 1 decimal place. So your answer needs to be to 1 decimal place. The student has then, for their accurate ones, done these to 2 decimal places. So your answer needs to be to 2 decimal places. What an irritating student. I would not like to teach that student because they have annoyed me. There we are. Just be vigilant with your decimal places. 4.5. Now, this one is the mark scheme. You're not going to see a grid method, but we could do this as a grid method. And I'm going to try and send you a question similar to this one. I'll make a note to myself. Similar to 4.5. One of these nice, using a titration to analyze something in a bit more detail. A lot of you got it, so well done. There's a technique here which I wonder if more of you would have got it had the description of the titration, those bullet points there, been on the same page as the question you were doing, because there's a bit where you have to multiply by 10 because of the dilution by 10. Okay, yeah, you got to do that. And that's more obvious if you were to use your highlighter and notice that the students made 250 centimeters cubed of the solution, but has done an experiment with only 25 centimeters cubed of it. So however many moles of stuff there were in that 25, we've got to times it by 10 to work out how many moles there were when we started. Okay, it's a common thing in those questions. Right, bear with me a moment.